Let's start by looking at x plus 2 and x plus 2x. Notice that since both terms in the first one don't have x's, we can't combine them. However, if the 2 were a 2x, like it is in the second pair of terms, they would be like terms, so we could combine them. 1x plus 2x equals 3x. Next, we can see that 3x squared and 9y squared have different variables, x and y, so we can't combine them. In the second pair, however, both terms have x squared, 3x squared and 9x squared, so we can combine them. 3x squared plus 9x squared equals 12x squared. In the third example, 7xy plus 7x, one term has both an x and a y, while the other term has only an x, so we can't combine them. In the other pair of terms, however, both terms have xy, so we can combine them. 7xy plus 7xy equals 14xy. Finally, 5x squared y plus 6x squared y squared both have x and y, and both x's are squared. However, y is to the first power in the first term, and it's squared in the second term, so these terms are not alike. If we make the y squared as well, like in the second pair of terms, we have all the same variables with all the same exponents or powers. So we can combine the like terms. 5x squared y squared plus 6x squared y squared equals 11x squared y squared. Notice in all of these examples, when we add the terms together, it doesn't change what the terms are. For example, when we add an x and a 2x, we still have x at the end. When we add x squared and x squared, we still have x squared at the end. An xy and an xy is again just xy. And finally, x squared y squared plus an x squared y squareds just give you x squared y squareds. Notice the exponents don't change and the variables don't change. This is important to remember, especially as we go on to our next lesson on multiplying with polynomials.